everyone, hope you are doing well. So in this video we will discover what are surds. I know you all are experts in square roots, so let us discover surds. So in this video we are going to discuss first what are surds, then we will discuss how many types of surds are there, then order of the surds, then we will discuss the operations of surds and some important questions and examples how to solve them very quickly, so that we will discuss. So please focus yourself and please take a note also, and let us practice and start. What are surds? I am writing here two types of numbers. You might have been acquainted with this: square root of 4 and you are getting answer 2. Square root of 9, you are getting answer 3. Square root of 16, you are getting answer 4, like this. Now I will tell you different kind of numbers like this. Square root of 2, what answer you are getting? Are you getting directly answers like this? Square root of 4 is 2? No. You will get answers like this: 1.414 ... Means this division process or this decimal expression will continue in a non-terminating and non-recurring. That means the numbers will not repeat like this, and it will be non-terminating or never ending. And similarly, root 3 also, square root of 3, you will get like this: 1.732 ... I have written up to 3 decimal places. You can find out up to more decimal places also, but not needed now. Now, root over of 5. The answer will be 2.236 ... like this. Some more values I will write like that. Root over of 6. The answer will be 2.2449 or 2.449. You can write 2.449 ... like this. Now root over of 7, 2.645 ... Then root over of 8, 2.828, like this. So kindly note down these values. These values will be helpful in further when you are solving the problems. Now see the type of numbers and these type of numbers. These type of numbers you can find the perfect square roots, but here you are not able to find the perfect square roots. So these kind of numbers are called surds. And now you just remember these values. It will be definitely helpful when solving the problem. I will tell you. So these are the surds. So surds are where we are not finding the perfect square roots. So now let us see the order of the surds. Let square root of a, or we can write a to the power 1 by 2, cube root of a, so we can write a to the power 1 by 3. Like this, if you go on, nth root of a will be a to the power 1 by n. So this we can say this is a surd having order 2. This is a surd having order 3. And this is a surd having order n. So like this. So this is called order of the surds. Order of the surds. Now after order of the surds, we will go for types of surds. Let us see types of surds. Types. First of all, we will see simple surds. Simple surds. Simple surds, very simple, as I wrote that: root 2, root 3, root over of 5, root over of 7, etc. Like this. These are simple surds. Now type 2, they are complex surds, or you can say mixed surds. Mixed surds, the mix, this word itself describes like this. Something will be mixed here, like 2 root 3 or 3 root 5 or 7 root 2, etc. You see, one rational number is there and one irrational number is there. This is rational and this is irrational. How irrational? Because in the beginning I told the value of root 2 1.414 dot 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 dot. That means the value of root 2, root 3, root 7, root 8, root 6, they are not ending in the decimal expressions. When you are finding the decimal values after decimal point goes on. It never ends. That is non-terminating and non-recurring. That's why they are the irrational numbers and these are the rational numbers. So rational number and irrational number, they are mixed together. So they are mixed surds, you can say. Then we will see another type of surd, number 3, that is compound surds. Number 3, you can say number 3, compound surds. In compound surds, like this, root 7 plus root 5, you see two surds are there, so they are compound, or you can say 7 plus 2 root 5, like this. These are called compound surds because some operation is there involved here, this addition is there, or you can minus number also, 5 minus 2 root 7, 5 minus 2 root 7, this is also compound surds. And after compound surds we will go for mixed surds. Mixed surds we have done actually, so now we will go for the like surds. Number 4, like surds. Like surds as in the like algebraic terms, suppose 7x, 5x, these are like terms you say in algebra. Suppose 2y and 3y, these are like terms in algebra. And in surds just like that, suppose the number is there 2 root 2 and 3 root 2, these are like surds. 5 root 7 and 6 root 7, these are like surds. You see, this irrational part is same, that's why they are like surds, you can say. And now after this, first we know what are surds, then types of surds, then order of the surds also I told. Now I will discuss about the operation of surds, which is very important. Let us go for operation of surds. So there are 4 types of operations, basic fundamental operations in mathematics, that is addition, subtraction, multiplication and division. So now here let us see addition first. So in addition, what we'll do, I will take one example. So it is 75 root over and 48 root over. Not much bigger numbers, very smaller numbers I have taken. Let us do addition here. In addition, what I will do, directly I cannot add like this. Some students, what they do hurriedly, they add 75 48 and they just try to find the square root of that, which is completely wrong. We will not do like that. Don't do like this. So how we will do? We will do like this. 75 is, it is 25 into 3, or you can go for a prime factorization method in the rough, or you can directly write. Then 48 means 16 into 3 root over. Now what you will do, 25 into 3 square root means 25 square root, that is 5. 3 square root we cannot find because again it's a surd. 25 root over is not a surd, but 3 root over is a surd, which we will directly write the value like this. We cannot find the exact value of that. So plus 16 root over is 4 into this is root 3. Now you can find 5 root 3 plus 4 root 3. 5 root 3 means there are 5 number of root 3's and this is 4 number of root 3's. If you add them, 9 number of root 3's are there. So 9 root 3 is the answer. This is the addition. Hope you understood. You can do, suppose subtraction is there. In the similar way, if I'll do subtraction of these numbers, subtraction, same procedure will be there, only here 75 square root minus 48 square root, suppose it is there. What I'll do, same, root 75, once you found this is 5 root 3 minus root 48 means again 4 root 3 And if you subtract 5 root 3 minus 4 root 3 is only root 3, because 5 number of root 3s are there. If you subtract 4 number of root 3s, the answer will be 1 number of root 3, only 1. So this answer is root 3, like this. And similarly, if it is there, suppose 4 root 3 minus 5 root 3, the answer might have been this one, minus root 3, right? Similar way, as you are subtracting, suppose 4x minus 5x, what could be the answer? Answer is minus x, just like that. The surds just behave like it. These are not algebraic terms, rather they behave like algebraic terms. Like terms you can add, like terms you can subtract, and in multiplication what will happen? Let us see one example. So quickly we'll go for the multiplication. Now same number I will take for multiplication. This is 75 root over into 48 root over. Why I am taking the same number? Because it will be easy to understand with comparison. How did you do the addition, how did you do the subtraction, then how we will do the multiplication, and similarly how we will do the division. So same idea, same kind of idea you will get, and you can compare with the previous one. Okay, so now again 75 root over will be, answer is 5 root 3. We will not write the whole steps because we know the answer. Wherever you know the answer, to save your time, you don't need to write everything, right? Some mental calculation must be done to save time. So this is 5 root 3 into this is whatever you got, 4 root 3. And now multiplication. When we are multiplying, just multiply the whole numbers. 5 4 ja is 20, and the root numbers or surds, root 3 into root 3, root 3 into root 3, right? So 20 into root 3 into root 3 means how much? Root 3 into root 3. That means suppose root 3 into root 3, that is root 3 whole square, right? 2 times it is multiplied, so square of root 3, and square of root 3 is, if you apply the rules of the sorts like this, root 3 means what? 3 to the power 1 by 2. As I told in the order of the sorts, square root of a means what? A to the power 1 by 2, right? Nth root of a is how much? A to the power 1 by n, right? So just like that, 3 square root is 3 to the power 1 by 2. This 2 is already there, so this 2 to cancel, answer is 3. That means this is the process actually. If I do the postmortem of this multiplication, this answer comes. But root 3 into root 3 is 3. Similarly, if we for practice we can say, we can speak out now, root 2 into root 2 is 2. Root 5 into root 5 is 5. Root 7 into root 7 is 7. Root 8 into root 8 is 8, like this. Simply, directly you can write. So 20 into 3, the answer is 60, right? So directly you can come from here to here the answer. These 2 steps can be avoided to save time, right? If you know the 5 root 3 into 4 root 3 mental calculation, 5 4 is 20, root 3 into root 3 is 3, 23 is 60, finish. Very quickly, within few seconds you can write the answer. Okay, so you can save the time. So this is multiplication. In the similar way, addition you saw, subtraction you saw, multiplication you saw. Let's see division. Now you go for division. So division, 75 root over divided by 48 root over. So now 75 root over is, again I will write, this is directly I will write 5 root 3 divided by 4 root 3. So this root 3 and root 3 multiplied in the numerator and the denominator is cancelled, and 5 by 4 is the answer. This is the answer. Finish. So in this way, maybe some difficult problems or higher level problems will be there, but the process will be same, and you will multiply and divide the rational part and rational part, and you just separate out the irrational parts and multiply and divide. Wherever these sorts are there like this, suppose a sort is like this, I will tell you 4 to the power 1 by 3 is there. What we will do here? 4 to the power 1 by 3, you can do 4 can be made as 2 to the power 2, and 1 by 3 is there, so 2 to the power 2 by 3, like this. According to the requirement, you can change this sorts in this form like this, then you can go ahead. Now what I'll do, we will solve few questions and examples for your confirmation and perfection that will definitely help you solve higher order problems. So let's start with some examples. So we'll do. So I will start with a very small example, that is finding 1 by root 2. Evaluate 1 by root 2. How to do that? See, in this kind of problem, the root 2 value we don't know actually. Evaluate means find the value, exact value you have to find. But how to do that? I told you in the beginning, I have given some values of the surds, root 2 values I have given, and root 5 values, root 3 value, root 7 value, root 8 value that I have given. So you please remember those simple values. Sometimes in some questions, the values of those surds might have been given. Above it is given, and at least you remember up to 3 decimal places to help you find these solutions. So what to do? So how I am doing here, see, if the denominator is an irrational number, then it is a bit difficult to solve. So let's first convert the denominator into a rational number. So how to convert the denominator into rational? That is 1 by root 2 is already there. So what I will do, how to make this rationalizing the denominator. So this is root 2 means another root 2 I will multiply. If root 2 into root 2 will be there, just before some time I have told you root 2 into root 2 is 2, root 3 into root 3 is 3, like that. So this will be 2. So now if you are multiplying root 2 in the denominator, you have to multiply root 2 in the numerator also. So answer will be root 2 divided by 2. Root 2 into root 2 is 2. So this is the done. Now what we will do, the value is not evaluated yet. So root 2 value you know 1.414 divided by 2. This division you can do. Now this simple division process you will write 1.414 divided by 2. Simply this is 14. So this is 2 7 ja 14. Now 0, 1 is remaining. So it will not go. So 2 zeros are 0, 1 is remaining. So this is 4. So 2 7 ja 14. Now the division process ends. But what we'll do, this decimal point, when you are dividing this, when you take the quotient here 7, you have crossed the decimal point, right? So what you will do, just put a decimal mark here. So answer will be 0.707. 0.707. So the answer is 0.707. Like this you will do. Similarly, if I hope you can understand this. Now similarly, if 1 by root 7 is there, again you can directly do like that. You may not do this step again. Once you know the fundamental, now directly you can go for this step, that is root 7 by 7, and root 7 value you know, this is 2.645 divided by 7. Now again similar way you can divide this by 7. So this is 26, 7 3 ja 21, remainder is 5, 54. Now what will do, 54 means 7 7 ja 49, remainder is just 5. So 5 is remaining. Again 7 7 ja is 49, 6 is there. Like this it will continue. Again put a 0 here and put a 0 here, it will continue like that. And so 0.3770 something, it will continue like that. So you will find the values like this. Next, this is simple denominator sorts. Simple sorts are there in the denominator. Now I will give complex denominator sorts. Let us see what to do. Tricks are there everywhere. You can find very easily. Now let's see another example of this kind. Root 2 minus 1 and root 2 plus 1. Now this question is evaluation question. So how to evaluate the value of root 2 minus 1 and root 2 plus 1? Let's do. Again you see the denominator. We are starting from the denominator because denominator troubles us. If any way we can make the denominator a rational number, then our division process will be very easy. So let's again rationalize the denominator. So to rationalize the denominator here, this kind of denominator, this is root 2 minus 1 written and this is root 2 plus 1 written. Root 2 plus 1, we have to rationalize this, right? So just remember that whenever this kind of number is been given, if this is root 2 plus 1, you multiply root 2 minus 1. If it is root 2 minus 1 is given, you multiply root 2 plus 1. So why? I will tell you in the next step, you will be clear why. So if you are multiplying root 2 minus 1 in the denominator, you have to multiply root 2 minus 1 in the numerator also. Now you see, root 2 minus 1 into root 2 minus 1 is root 2 minus 1 whole square divided by root 2 plus 1 into root 2 minus 1. This formula will be a plus b into a minus b kind of formula. So in place of a, which is there, root 2 plus 1, a plus b, and this is a minus b. If a plus b into a minus b is what? A square minus b square. Simple algebraic formula. A square minus b square. First number square minus second number square. That is root 2 square minus 1 square. So we will get the answer what? Root 2 minus 1 whole square. Again, root 2 minus 1 whole square will be a minus b whole square formula. A minus b whole square is how much? A square minus 2ab plus b square. Simple algebraic formula. A square minus 2ab plus b square. A minus b whole square. So we will put that a square means root 2 square minus 2 into ab. A means root 2 into b means 1. Very simple. Plus 1 square. A square minus 2ab plus b square. Numerator work is done. Now denominator, root 2 square is how much? Again come to the previous step which I told you. Root 2 into root 2 is 2. Root 3 into root 3 is 3. Root 7 into root 7 is 7. So root 2 square is 2. Finish. And minus 1 is there. 1 square. So now root 2 square is again same fundamentals are being used repeatedly, right? So if you remember some fundamentals, some basic concepts, you can solve many problems. Root 2 square is 2 minus, this is 2 into root 2, this 1, okay, 2 1s are 2 into root 2, 2 root 2 plus 1 divided by 2 minus 1 is 1. So this is 2 plus 1, 3 minus 2 root 2 by 1 we will not write. So 3 minus 2 root 2 is the final answer. And here, this is the answer in irrationals. If you are being told to evaluate the number, what we will do simply is 3 is been given, minus 2 is there, into root 2 value you know, 1.414. So that value you will multiply 3 minus, this is 2 4 ja 8, 2 1 ja 2, 2 4 ja 8 and 2 1 ja 2. So this will be subtracted. 3 minus 2.828, what will be the answer? This is 3.000 and this is 2.828. This 0 is not required, so we'll end up here. So this is 2, this is 10 minus 8 is 2, so 9 minus 2 is 7, 9 minus 8 is 1, so this is already gone, so 0.172 is the answer. 0.172 is the answer. So this way you can find out. First, rationalize the denominator, then do the process whatever is required, and then if the value is required you can do, or if value is not required you can stay here. Okay, so this is one example. Another type of example I will give. Suppose in the denominator, here the question we solved, root 2 plus 1 was there, so you multiplied root 2 minus 1. Again I am telling, if root 2 minus 1 would have been there, you might have multiplied root 2 plus 1. Okay, so now we will go for another example. Root 7 minus root 5, root 7 plus root 5. How to do that? Again you see this kind of is there. So what we will do, I will tell you a trick here. Same way, by rationalizing the denominator you can do, but if both the numbers are irrational, but in the previous question, see I am writing the previous question. This is root 2 minus 1 and root 2 plus 1 was there. Both the numbers are not irrational. Here both the numbers are irrational. You see root 7 and root 5 both are irrational. So what method you will apply? The question might be like this. This is root 7 plus root 5, root 7 minus root 5. You see the difference. You see the difference. This is for reference from the previous. This is now present condition. Which one I am solving? This is minus, this is plus, this is plus and this is minus. Just the reverse has been given. So what formula you will apply? You will apply, what you will do, you see root 7 and root 5 are there. So in both the solutions, just write whose root is there? Root 7 is there. Write 7. Whose another root is there? 5. Write 5. 7 plus 5. Here also 7 plus 5. Same, not different. 7 plus 5 divided by, in the denominator also same you will, I'll just keep a space here. Then here 7 minus 5, here also 7 minus 5. In both this, whether this is minus, whether this is plus, no matter. If you see two irrational numbers like this and same numbers are added and same numbers are subtracted in the denominator, in the numerator numbers are added, in the denominator same numbers are subtracted, formula is like this. Formula is like this. So then something is left, don't worry. So minus 2 into root over of this 2, here also minus 2 into root over of, what are the numbers? 7 into 5. Here also 7 into 5 divided by. You see, same type. If this is minus, this is minus. If this is plus, this is plus. Just simple change. Remaining everything is same, everything. And here 7 minus 5. Here 7 minus 5. You see, this is same, this is same, this is same, this is same, and here also 7 minus 5. Yes, these are same. Only change is this is also same. You can see now only this minus and this is plus. Only simple difference. If this is minus, give a minus here. If this is plus, give a plus here. Remaining rest are same formula. Okay, now we'll do the answer. This is 12. 7 minus 5 is 2. Minus 2. This is 35. Root over divided by 2. Now we can do, you can unite this. 2 is the LCM. So this is 12 minus 2 root 35. You can write. Or you can write like this also. Your wish. This is 6. 6 minus, this is 2 to cancel. This 2 and 2 cancel. 6 minus root 35 is the answer. Here, what will be the answer? You see, this is again 12 by 2 plus this is 2. This one and this is 2. So this 2 to cancel, this is 6. So 6 plus root 35. So finally we got an answer here actually. We got an answer here. So and we got a formula here. Answer not much different, but the formula will be like this. I am writing the formula here. Root A minus root B by root A plus root B is equal to, I will not write the right part. Right part I will write at once. Again root A plus root B by root A minus root B. You can see here, here minus is in the numerator, numerator, plus is in the denominator. Here plus is in the numerator and minus is in the denominator. But the numbers at the right side will be same. How? Here A plus B by A minus B. Here also A plus B by A minus B. And here it is minus and here it is plus. Why minus? Because minus is in the numerator, this is minus. Plus in the numerator, this is plus. Remaining all are again equal. 2 root AB divided by A minus B. Here also 2 root AB divided by A minus B. So this is over. This formula will help you solving this kind of questions. This kind of questions. Do you remember then? So this is the direct formula where you can solve like this. Now I will tell you another example. So let us do that. Last example. So then you will practice many examples and you can go ahead. So root 5 plus 1 and this is root 5 minus 1 root over. You can see root over. Are you astonished? No. This is also easy. Let us see. Same kind of question is that. See, now root 5 minus 1, stick to the basics. Stick to the basics. What I told. If denominator is irrational, make it rational. Make it rational. So root 5 plus 1 into root 5, what I will see. Now root 5 minus 1, what will multiply? Root 5 plus 1. So this is also root 5 plus 1 and square root is already there. Now what I will do, this is root 5 plus 1 whole square and this is root 5 plus 1 and root 5 minus 1 into means a plus b into a minus b, that is a square minus b square. So root 5 square minus 1 square, root 5 square is 5 and 1 square is 1. So 5 minus 1 is 4. whole square root again. So now in the next step what we'll do, let us see root 5 plus 1 whole square, root 5 plus 1 whole square root divided by 4 square root. This step can be avoided. To avoid lengthy writing, you can avoid this step also, no problem. Directly you can come to this step, I am telling you. So root 5 plus 1 simple minus 4 root over is 2. See how simple is this? How simple is this? So now this is root 5 means you put the value. Root 5 value is how much? It is 2.236 plus 1 divided by 2. Now you can add. So this is 3.236 by 2. It can be divided, divisible, right? Again the same process you will apply. 3236 by 2. So this is 2 1 ja 2, remainder is 1, then this 2 will remaining. So this will be decimal you have crossed, so point given. So 1 6 2 6 ja 12, then 0. So this 3 will be coming, 1 ja, this is 2, so this will be 1, then 6, 2 8 ja, like this the answer will come. So this is 1.618, the answer will come. Okay, so you have got this answer. So now I have told you different formula. This kind of things you can use. This is looking a bit complex, but if you stick to the basics, you can solve very easily. Like this, many problems you practice at home so that you will be perfect, because practice will only make you perfect. So hope you like this video and you go on discovering this kind of maths and be passionate about maths. Definitely that exploration will develop you to the fullest. And if you like this video, don't forget to stay tuned with us so that we will come up with very exciting and new videos. Thank you. Have a nice day.